66 million years ago. At the end of the Cretaceous, dinosaurs ruled the Earth. But at that moment, two great changes were unfolding. From the sky, a massive asteroid, and deep within the planet, a reversal of Earth's magnetic field. This period in geomagnetic time is called C29R, a time when Earth's magnetic poles were reversed. But when we look at Earth's history, magnetic fluctuations are sometimes linked not only with extinctions, but also with major climate transitions, ice ages, climate shifts, evolution itself. Earth is not a planet driven by a single cause. At the very end of the Cretaceous, C29R represents about 400,000 years when Earth's magnetic field was reversed. Within that interval lies one of the most famous boundaries in geology, the KPG extinction event, the moment when the dinosaurs vanished. Around the world, this boundary is marked by a thin layer of iridium, a signal of an event that happened in a very short time. The dominant theory points to the Chicxulub crater on Mexico's Yucatan Peninsula, a massive asteroid impact considered the primary cause of the extinction. Dust thrown into the atmosphere blocked sunlight, triggering an impact winter. Within hours, shock waves spread across the planet. Within years, sunlight was reduced, food chains collapsed. This explanation is extremely powerful. But a question remains. Why did some amphibians, small reptiles and early mammals survive? They could burrow underground. They were omnivorous. Their generations were short. Gigantic size was not always an advantage. Extinction was not uniform. Survival had conditions. The Earth at the end of the Cretaceous was not quiet. In India, the Deccan traps erupted for hundreds of thousands of years. Carbon dioxide, sulfur, acid rain. And during this time, the planet was also in a reversed magnetic state, C29R. The magnetic field may have weakened. Cosmic radiation may have increased. Ozone layer variations have been suggested. We cannot say for certain. But we can ask a question. Perhaps the asteroid was not the beginning. Perhaps it was the final blow. Now consider another rhythm of our planet. The widely accepted driver of ice ages is the Milankovitch cycles, changes in Earth's orbit, changes in axial tilt and axial precession. But these variations are extremely small. Yet these small orbital changes can produce massive continental ice sheets. Such changes require powerful feedback within the atmosphere and the oceans. Some researchers have explored another possibility. When the magnetic field weakens, cosmic rays increase. These particles may influence cloud formation and climate systems. This idea remains a hypothesis. There is no firm proof. Earth's magnetic field is generated by convection of liquid iron in the outer core. If those flow patterns change, the magnetic field changes. But could small variations in Earth's rotation or axial tilt affect that convection? This remains an open scientific question. Earth is a coupled system, core, mantle, oceans, atmosphere, all interacting. Magnetic reversals do not happen instantly. They may take hundreds to thousands of years. During that transition, the field becomes unstable. Multiple poles may appear. The magnetic shield weakens and shifts. And yet the planet continues. After the dinosaurs disappeared, terrestrial ecosystems collapsed. But the ocean became a refuge for evolution. Earth did not end. It reorganized. Life rebuilt. And around 50 million years ago, an animal stood at the water's edge. Pakicetus, a four-legged terrestrial predator. Yet its inner ear resembled that of whales. Then came Ambulocetus, amphibious, transitional, eventually fully marine. And today, giant whales rule the seas. If the Cretaceous hadn't ended, would this have happened? Today, the situation is different. We have built civilization under the protection of Earth's magnetic field. Satellites, power grids, GPS, artificial intelligence. If the magnetic field weakens, cosmic radiation increases. Semiconductors become more vulnerable to errors. Satellites exposed to radiation may malfunction, disrupting communication, navigation, and weather forecasting. If strong solar storms coincide, geomagnetically induced currents can surge through transmission lines. Transformers may fail. The 1989 Quebec blackout was one example. Large-scale geomagnetic disturbances could disrupt logistics. Financial systems could freeze. Extended power outages could shut down data centers. AI, cloud infrastructure, the internet, all depend on electricity and cooling. The digital world rests on physical systems. Supermarkets could empty within days. Earth would continue. But what about civilization? If the Cretaceous had not ended, if dinosaurs had survived, would mammals have entered the oceans? K29R, volcanism, asteroid impact, coincidence, or a planetary tipping point? Perhaps destruction prepared the way for creation. Earth cycles. Magnetic fields fluctuate. Life adapts. But civilization has never faced planetary-scale selection. The question is, can we adapt? Perhaps the test approaches slowly. And even now, we continue to fight one another. Science explains the universe. The question is how humanity will respond. This is ReWorld Project.